Hey guys, we are going to work today on solving equations with radicals. Last week we looked at how to multiply radical expressions, how to divide radical expressions, and how to rationalize denominators when there was a radical in that denominator. So for our notes today, these skills are imperative for special right triangles, which is our next unit. So I first want to review the properties of radicals. So when we are multiplying radical expressions, remember that you can multiply coefficients and their product is a coefficient, and you can multiply radicands and their product is still a radicand. So an example here, if we have 3 square roots of 6 multiplied by 2 square roots of 3, okay, my coefficients are 3 and 2, so I'm going to multiply those, and I have a coefficient of 6. My radicands are 6 and 3. I'm going to multiply those, and my radicand is 18. Okay. Always simplify, so just a quick review of simplifying here. Take a look at the radicand. If it has any factors that are perfect squares, then you can simplify. Factors of 18, we're going to use 9 and 2. 9 is a perfect square. Okay, so we rewrite the square root of 18 as the product, square root of 9, square root of 2. Notice that 6 coefficient just came on down. Then we take the square root of 9, which is actually 3, and then the square root of 2. And then we want to, again, multiply those coefficients. So we get 18 square roots of 2. Okay, that's my final product there. So again, another reminder about dividing radical expressions. If you had the square root of a divided by the square root of b, you can write that as one radical with that quotient underneath as your radicand. Okay, that can be very helpful when you are simplifying. Okay, so a quick example there. If I have the square root of 50 divided by the square root of 6, okay, if I put that under one radical, 50 over 6, well, it doesn't simplify to be an integer. It does simplify a little bit though, so I would get the square root of 25 over 3. Okay, square root of 25 over 3. But I can't have a fraction under there, so I need to break it apart again and then evaluate the numerator and the denominator. Now the square root of 25 is 5, so that's nice. But then I have that radical in my denominator, which leads me to a quick reminder for you guys about how to rationalize. We can never have a radical in the denominator. So since I have that square root of 3 in the denominator, that's not simplified. So rationalizing is the process of getting the radical out of the denominator. So what I want to do here is multiply by the square root of 3 over the square root of 3. Okay, I picked the square root of 3 because that's what my denominator is. You'll notice that I'm multiplying by the same number over itself. That's equivalent to 1. When you take a fraction, you multiply, or take anything, multiply it by 1, you're not changing the value, you're just changing the way it looks. Okay? As we multiply fractions, we go across the top, across the bottom, so my product in the numerator is 5 square roots of 3. My denominator, square root of 3 times square root of 3, is the square root of 9. Well, the square root of 9 is 3. And that can't be simplified any further. Okay? This 3 is really the square root of 3. And this 3 is 3. So they're not like terms because one is under the radical and one is outside of the radical. Okay, so this is actually the final answer for simplifying or dividing the square root of 50 divided by the square root of 6. All right. So again, no radicals in the denominator. You have to rationalize that denominator, and that's this process here where you're getting that radical out of the denominator. So I've got 4 examples for you guys, and then you have several opportunities to practice today. All right, so our first example here, again, our goal is to solve equations with radicals in them. So if I were looking at this proportion here, 2 divided by the square root of 3 equals 6 divided by the square root of x. You guys are very familiar with proportions. Okay, you can solve a proportion by cross multiplying. That means that your cross products are equal. So the product of 2 and x is equal to the product of 6 square roots of 3. All right. I want to get x by itself, so nice and easy. Okay, I can just divide both sides by 2. 2's over there cancel out. That does isolate x over on the left-hand side. On the right, when I'm simplifying, I have a 6 and a 2. Neither of those are under the radical, so they can be divided. They can be reduced there. 6 divided by 2 is 3. So my final answer to that example is 3 square roots of 3. All right, and that is a simplified answer. Okay. Second example here. Square root of 3 over 1 equals 4 over x. Okay, again, I have a proportion. All right, solve a proportion by cross multiplying. My cross products are equal. So if I multiply x in the square root of 3, I like to put the x in front as a coefficient. If I have it at the back, sometimes it looks like it's under the radical, which can be misleading, so I like to put it in the front. And then my other cross product is 4. Okay, so x times the square root of 3 is equal to 4. So I need to get x by itself. Well, this is being multiplied, x times the square root of 3. I can undo multiplication by dividing. My square root of 3's cancel. So x is equal to 4 divided by the square root of 3. However, I have that radical in the denominator, so that's my answer, but it's not simplified. So I need to rationalize my denominator to get the radical out of the denominator. I'm going to go ahead and multiply by the denominator over itself. Remember, I'm multiplying by a fraction equivalent to 1, so I'm not going to change the value, even though I am changing the way it looks. Multiply your numerators together. 4 square root of 3. One's out of the radical, one is under the radical, so I can't put them together. Just leave that 4 as a coefficient. And for our denominators, the square root of 3 times the square root of 3 is the square root of 9. But we know the square root of 9 is 3. So my final answer here, x is equal to 4 square roots of 3 over 3. Okay. All right. Example 3. I have 1 over the square root of 2. And you're going to be seeing equations like this in this section. Okay. So again, I have a proportion. Cross multiply. Well, that's really nice. It's going to be a 1x. Okay. X is already by itself. So that's good. Now I want to multiply my radicals. The square root of 2 times the square root of 3. I can multiply the radicands and leave that as a radicand, so I get the square root of 6. Can that be simplified? Well, does 6 have any factors that are perfect squares? Nope, it doesn't. Factors are 2 and 3. They're not perfect squares, so that is my final answer on that one. Okay, and then one more here. Our last example is 1 over the square root of 2 is equal to x over 2 square roots of 3, and then we are solving for x. So once again here, let's go ahead and cross multiply. Okay, my cross products, I get x times the square root of 2 equals 2 times the square root of 3. Okay, I want to get x by itself, so I want to go ahead and divide both sides by the square root of 2. Right. Well, then I have x equals 2 square root of 3 divided by root 2. I see that I have that 2, that radical 2 in my denominator, and I can't have a radical in the denominator. I need to simplify. So I'm going to rationalize. This time I want to multiply by root 2 over root 2. Remember, we're going to multiply by what's in the denominator, okay, over itself. So when I multiply across the top, my 2 coefficient needs to stay out in front. I can multiply my 2 radicands. That would give me the square root of 6. And then the square root of 2 times the square root of 2, multiply those radicands, you get the square root of 4, which can be simplified. Some of you might be noticing a pattern here. Okay, the square root of 4 is 2. And this can actually be simplified because I have a 2 in my numerator and a 2 in the denominator. Neither of those are under a radical. They're both outside, so we can go ahead and cancel those out. So our final answer is x equals the square root of 6. Okay, so that's my final answer. So you guys are going to go ahead and take a few minutes. You've got 4 problems on the front, and then about 6 or 8 on the back, solving equations. Those answers will go up on the board in about 10 minutes. So take your time, ask some questions if you have them. Review the video if you need to look at one of those examples at any time. Help session on Wednesdays.